This week in Math 278, we're still working in the 7th grade. This time we're working on geometry. There are a lot of different components, even though the standards don't look like a lot. There's a lot of different things happening within them. Supplementary, complementary, adjacent, and vertical angles form important relationships. We can find angle measures with equations that show the relationships between these angles. So let's assume that the MP is perpendicular to QP. Find the value of X. Well, right away, I see that these two that are across from each other, these are vertical angles, so these are equal to each other. I also know that these two adjacent angles to one another need to add up to 90 degrees based on the 90-degree angle over here. So if these two are equivalent, and I know that these two add up to 90 degrees, I can say that 60 minus x plus 2x minus 5 is equal to 90. I then can simplify my parentheses. We can combine like terms since negative 1x plus 2x is 1x, and 60 minus 5 is 55. I need to subtract 55 from both sides, so x is equal to 35. Find the value of x and y. We'll assume that CA and BE are perpendicular to one another. I see that angle X is a vertical angle to angle DAE here. Further, I know that it is adjacent, and these two together must be 90 degrees. Therefore, x plus 74 is 90. I subtract 74 from both sides. We get x is equal to 16. I also know that angle 16 here plus y, all of this, because these two are adjacent together and they form the line BE, must equal 180 degrees. So to find y, we subtract 16 from both sides. So y is equal to 164. Determine how many triangles can be formed given triangle ABC with length AB of 6 2/10 centimeters, BC is 3 1/10 centimeter, and angle A is equal to 14 degrees. So I'm going to lay down a line AB and measure out 6.2 centimeters. Then I will create angle A using 14 degrees with my protractor. Connecting where they should to create 3.1 centimeters off of angle B, that will be angles, that will hit the vertex angle C. Now imagine me shifting this 3.1 over this direction here. So we just kind of shifted it. It will hit our dotted line of the 14 degrees one more time, which means that I can form two different triangles based on those measurements. Determine how many triangles will be formed given the side lengths 2.5 centimeters, 3.4 centimeters, and 6.0 centimeters. So I have the different triangles laid out here. And just hold on real quick here. I'm going to show you some things, and then we're going to talk about it. So if I were to add together the purple and the blue and the green, we would get 8.5. So 8.5 is greater than the other length, 3.4, so that's okay. If I were to add the purple and the blue together, we would get 9.4, which is greater than the third length of 2.5. That's okay as well. However, if I were to add 3.4 and 2.5, we get 5.9. That is not greater than the other length, so this is not okay. Because the sum of two lengths of the triangle is not greater than the third side for all three different sets, no triangle will form. Determine if a unique triangle, more than one triangle, or no triangle will form given the following attributes: 30 degrees, 60 degrees, and 90 degrees. A triangle has a total of 180 degrees. So 30 plus 60 plus 90 is 180 degrees. Further, there could be many different lengths of sides that make up these triangles with those degrees. Therefore, more than one triangle can be formed. Scale drawings may be smaller, larger, or the same size as the original. Find the scale dimensions given the original figure and a scale factor of 3. So our original figure is 4 millimeters by 2 millimeters. If I want to scale this by 3, 4 times 3 is 12, and 2 times 3 is 6. So the new size must be a 6 millimeter by 12 millimeter. Notice that my side grew by 2, 4, 6, and this side grew by 4, 8, 12. Find the scale dimensions given the original figure and a scale factor of 3/4. We're starting with an 8 by 12. So 3/4 of 8 is 6, and 3/4 of 12 is 9. So our new rectangle must be a 6 by 9. It is 3/4 the size of the original rectangle. To find the dimensions of a scale figure by multiplying the original dimensions by the scale factor. A scale factor of 4 was used to create this rectangle below. What are the dimensions of the... So we ask ourselves, what times 4 would give us 3, and what times 4 would give us 5? We do not know the original dimensions yet. So we can replace the question mark with a variable. So 4x equals 3. When we divide each side by 4, x is equal to 3/4. On the bottom side here, 4x equals 5. Divide by 4, so x equals 5/4. The dimensions of the original rectangle is 3/4 inches by 5/4 of an inch. Perimeters of scale figures are proportional to the perimeters of the original figures. Find the perimeter of the scale drawn given the perimeter of the original and the scale factor. So we have the perimeter of 38 centimeters, and we're giving this a scale factor of 2. So 2 times the side length of 10 would be 20, and 2 times the side length of 9 would be 18. So 2 times the perimeter of 38 would have to be 76. And if I were to add 20 plus 20 plus 18 plus 18, we would get 76. 76. Find the perimeter of the scale drawing given the perimeter of the original and the scale factor. So the original perimeter is 45 and the scale factor is 3. We know that we can take the perimeter and multiply by the factor to get the scale perimeter of our new one for 135 centimeters. Find the perimeter of the original figure given the perimeter of the scale drawing and the scale factor. So this is now scaled. We want to know what the original one is. So instead of multiplying, we will divide. 9 divided by 3 is 3 for one of our sides. The second side would be 6 divided by 3, so 2. And then the perimeter, 30 divided by 3, would be 10. Find the perimeter of the original figure given the perimeter of the scale drawing and the scale factor. So our perimeter of our scale drawing is 10. We want to know the original, so we need to divide by the scale factor of 5. So our perimeter is 2. Areas of pairs of scaled figures are related by the square of the scale factor. Given a scale factor of 3 and the image below, find the area of the scaled figure. So the area of our scaled figure will be as follows. Notice that our original figure had 3 across. So we need to take this 3 across and multiply it by 3. So it's now 9 across. Further, it is 1 down multiplied by 3. So 1, 2, 3. This is 27 square units. So the area of our original is a 1 by 3 multiplied by the square scale of 3 squared. So the scale factor squared times the original area. Given a scale factor of 1/2 and the image, find the area of the scaled figure. So the area of the original figure is 8 times 4, so 32. The scaled area then is the scale squared, so 1/2 squared times the area of 32. 1/2 squared is 1/4, and 1/4 of 32 is 8. We can verify this by taking the scale of the side length of 4 as 2, and half the side length of 8 is 4. Charlie says since everything on an elementary field is scaled by a factor of 2/3, it means the following. You need to hit the ball 2/3 the distance to get a home run. You need to run 2/3 the distance to run around the bases, and there is 2/3 as much grass in the infield. Do you agree with him? Why or why not? I have pictured their professional field. We know that the dimensions and area of a scale drawing relate to the original dimensions and area by the scale factor and the square of the scale factor. So the area of a pro field, since it is a square, is 90 times 90, so 8,100. The distance around the bases is 4 times 90. Since from home plate to first is 90, first to second is 90. Oh, that must be home plate. Home plate to first is 90, first to second is 90, second to third is 90, and third to home is 90. So a distance is 360 feet all around the bases. So let's find the area multiplied by the scale factor. So the total area of the pro field is 8,000 times the scale factor of 2/3 squared. That gives us 8,100 times 4/9, which is equivalent to 3,600. The distance around the bases multiplied by the scale factor. Since we know perimeter, we just need to multiply, but not by the square. Just multiply by the factor. So 360 times 2/3 is 240. The dimensions multiplied by a scale factor. So 90 times 2/3 is 60. So one length is 60. Then 60 times 60, since that is the scaled portion, is 3,600, and 60 times 4 is 240. So Charlie is correct. Take a moment to pause the video and identify what you feel you need to know in order to answer the questions below: radius, diameter, or circumference. How far from the center of a flower pot to the edge? We would need the radius. If we're sitting on a Ferris wheel, how far do you travel? Knowing that we go around in a circle, we would need to know the circumference. Brushing olive oil on a pizza crust, assuming we're needing to find the area of the pizza crust, the whole pizza crust, we would need either the diameter or the radius. Outline the center circle on a soccer field. How much chalk is needed? So since we're looking at the outline of a circle, we're looking for the circumference. What size pizza box do I need? We could either use the diameter or the radius to identify how wide our pizza is. How long is the minute hand on a clock? This is looking at the radius. Shipping a clock, what size box do I need? Again, probably the diameter or the radius because we can use one or the other to find each other. Inscribe a circle in a square. How big is it? Here again, we can use the diameter to find the circumference, or it just depends exactly what specific things we're looking for. What size tire fits on a rim? The diameter, which would then help lead to the circumference. And depending upon the information that we're given based on the information from the rim itself. Jesse needs new back wheels for his tricycle. May brings over a wheel with a radius of 7.5 inches. Ashley brings over a wheel with a diameter of 15.25 inches. Will these work for Jesse? Well, if I took 7.5 times 2, that would be a 15-inch diameter. So these will not work since they are not the same. One would be 15 inches and one would be at 15.25 inches. The relationship between the circumference of a circle and its diameter is called pi. Circumference is known as pi times diameter. We use pi, which is a constant. The circumference of a circle can be found when given the diameter or the radius, since we can use the radius to find the diameter. What is the circumference of a circle with the diameter of 33 inches? Round your answer to the nearest tenth. So circumference is equal to pi times 33. We're given the diameter. We use 3.14 for pi, so 3.14 times 33 gives us 136 inches. What is the circumference of a circle with a diameter of 12 inches? Round your answer to the nearest tenth. Pause the video to see if you can do this one on your own. Circumference is pi times 12. Or 3.14 times 12, which is 37 7/10 inches. Let's complete the table. If I know the radius, I know the diameter, I can then find the circumference. We know that the diameter is twice the value of the radius, so our diameter is 12 centimeters. Therefore, the circumference, we'll get to that column here in a second, I can find the radius of my diameter of 12 centimeters by dividing in half. And similarly, if I take 18 over pi divided by 2, which is the same as multiplying by half, I end up with 9 over pi centimeters. So now let's work on finding the circumference. 3.14 times the diameter of 12 is 37 7/10 centimeters. 3.14 times 24 gives us 75 4/10 centimeters. And 3.14, again, we're using pi times 18 over pi. Notice that our pi's would cancel and we'd be left with 18 centimeters. At the county fair, the Ferris wheel is 45 feet tall. You buy a ticket which lets you go around 5 times or 5 revolutions. How far did you travel? Round your answer to the nearest foot. Well, 45 feet tall would be the diameter from the bottom to the top of the Ferris wheel. So I can take 3.14 times 45, which gives me 141.3, or rounded to the nearest foot, part B. However, we're going 5 times around, so I would need to take 5 times the one circumference, giving me 141.3 or 706.5. This is the correct answer for part A. A telescope is made with 3 mirrors that are all the same size. If the diameter of each mirror is 4 inches, what is the total circumference for all 3 mirrors? So to find the circumference of one mirror, we would take 3.14 times the diameter of 4, which gives me 12.56. Conveniently, that's part C, but we have 3 mirrors. So I need to take that times 3, giving me 37.7, or rounded to the nearest whole number, 38 inches, so part B. The relationship between a circumference and the diameter. So I can find the circumference by taking pi times the diameter, or 2 times pi times the radius, since 2 times the radius is the same as the diameter. The top of a tennis ball has a circumference of 88.5 inches. A standard tennis ball is 2.7 inches in diameter. How much extra space is in the diameter? First, I'll take, knowing that the circumference is 8.5 inches, I can then find the diameter of my can by dividing by 3.14 to obtain the diameter by itself. By doing this, I see that the diameter of the tennis ball can is 2.706. So then I can take the diameter of the tennis ball can and subtract the diameter of the tennis ball, giving me just a very teeny tiny 0.006, or 6/1000 of an inch extra space, which isn't a whole lot. The circumference of the front tire on Jake's bicycle is 88 inches. What is the length of one of the spokes? So the spokes would be the radius, which is why I'm using circumference is equal to 2 pi r, so I can identify the length of the spoke. I know the circumference is 88 inches, so I can fill in the rest to find r. So 88 equals 2 times 3.14 times r. Dividing by 2 times pi, I end up with 14.01, which is the radius of one of the spokes of the tire. Circles have an area just like any other figure, and the area of a circle is, of course, related to the radius of that circle. So area is equal to pi times radius squared. If the top of a cake has a radius of 6.5 inches, do we have enough icing to cover it? Knowing that the can of icing says it covers 121 square inches. So let's first find the area of the cake. So area is pi r squared. We'll use pi as 3.14. We know the radius is 6.5. So if I use my order of operations, I see that 132.67 square inches is the area of the top of the cake. However, our icing only covers 121 square inches. So since 132.67 is not less than 121, the area we have, we do not have enough icing, since this does not make a true statement. Rebecca wants to order a pizza for her slumber party. How much more pizza does she get if she orders a large instead of a medium? A medium is a 14-inch diameter and the large is a 16-inch diameter. So the large pizza area is equal to pi r squared. We need to take 3.14 times the radius. Now we're given the diameter. The radius is half of the diameter, so 8 squared. Multiplying, we get 200.96 square inches of pizza for the large one. Now let's look at the medium pizza using the same formula, except this time our radius is 7, so half of 14 is 7. Multiplying using our order of operations, we see that a medium pizza covers 153.86 square inches. So the area of the large pizza minus the area of our medium pizza will tell me how much more pizza I get with my large. So 200.96 minus 153.86 means that we get 47 1/10 extra square inches of pizza for our large pizza. Paisley drew a circle inside of a square that the circle perfectly touched all 4 sides. The length of the side of the square is 16 centimeters. What is the area of the circle? So I know that the length of one side would be 16. So the diameter of my circle would be 16, and my radius, therefore, would have to be 8. So 3.14 times 8 squared gives me 200.96 square centimeters for the area of the circle. What is the ratio of the area of the circle to the area of the square? Express your answer as a percent and round to the nearest tenth of a percent. Well, we already know that the area of a circle is 200.96. We can divide that then by the area of the square, which we can find as well. So the area of a square, knowing that each length is 16, would be 16 times 16, or 256 square centimeters. So if I write this as 200.96 divided by 256, we get 0.785, or 78.5% rounded to the nearest tenth of a percent. How does the name of each figure related to the number of faces and shape of each face? So when I take a look at each individual one, I see that that first shape is a pentagonal prism. A pentagon has 5 sides, so therefore we have 5 faces and 2 bases. Each one of our bases will be the pentagon, hence the name pentagonal prism. Our second shape is a trapezoidal prism. We know a trapezoid has 4 sides, so we'll end up with 4 faces and 2 bases. Each one of those bases will end up being a trapezoid. The third one is a triangular prism. Triangles have 3 sides, so 3 faces, and each one of the bases will be a triangle. How do you know where the bases are on a rectangular prism, considering all the sides will end up being a rectangle? Which means that we can use any of the opposite congruent faces to classify them as the bases. For non-rectangular prisms, they have 2 special faces called the bases, such as the 3 examples above. The bases are faces that are not rectangular shapes. The bases are opposite and congruent, just like the 3 examples above. Surface area of any figure is the sum of the area of all the faces of the figure. Surface area can be calculated for any figure using the formulas for each of the area of the faces. So here we have a triangular prism. Let's find the surface area. We have 3 rectangles and we have 2 triangles for each of the bases. The area of a rectangle is length times width. So we have a rectangle that is a size 6 times 4.5, which is 27. We have one that is 6 times 7, so the one that's facing us. And we have 6 times, so this side will be 6, and by 3.6, so this right-hand side, so 21.6. We have the area of a triangle is half times base times height. So we have half times our base of 7 times the height of the triangle given, which is 2. And that is 7, so we've got 2 of those. We can add all of our areas together to give us a grand total of 104.6 square centimeters for the surface area of this triangular prism. Find the surface area of the figure. Here we have a rectangular prism. So we have 4 rectangles, and notice that we have 2 squares here at the end, and then the rest are rectangles. So the area of a rectangle is length times width. So one area would be 13 by 5, so 65. But if you notice, there are 4 of the same. So 4 times 65 is 260. Area of a square is the same length times width, so 5 times 5, which is 25. And we have 2 squares, one on each end. So 2 times 25, or 50. Adding all of our surface areas together, we have 260 plus 50, so 310 square feet. Let's find the surface area of the square pyramid. We have 4 triangles, and all of the triangles will be the same, and we have 1 square on the bottom. So the area of a triangle is half times base times height. So half times our base of 8.9 times the height, which it's pointing to at 9 and 9.4, so 41.83. Notice that we have 4 triangles that we need to find the area of, so altogether 167 and 32 hundredths. The area of the square is length times width. So 8 9/10 times 8 9/10 gives us 79.21. Adding them all together, we get 246 and 53 hundredths square inches. The volume of a prism can be found by multiplying the area of the base times the height of the figure. What is the volume of the figure? So the volume is base times height. Here we have a triangular prism. The area of our base is a triangle, so the area of the base is half times base times height. So half times 8 times 5 is 20. And we want to take 20, how tall our prism is, which is 10 centimeters. So 200 cubic centimeters is the volume of this triangular prism. Let's find the volume of this trapezoidal prism. So notice our base is a trapezoid. So we need to find the area of a trapezoid, which is half times the base 1 plus base 2 times the height of the trapezoid. So half times 2.3 meters plus 1.9 meters times the height of 1.7 meters. That gives us half times 4.2 times 1.7, so 3 57 hundredths meters of the trapezoid. We need to take that times the height of our trapezoid, or the length in this particular case, which is 4 meters. And I didn't have that screen done, so we'll do that screen here. So volume is 3.57 times 4, which is 14.28 cubic meters. The volume of a pyramid can be found using the formula volume equals a third times its base times its height. So here we have a square pyramid. The area of the base, and our base is a square, is length times width, so 36. So the volume is 1/3 times 36 times the height from the middle to the tip of our pyramid of 4 is 48 cubic centimeters. Let's find the volume of this triangular pyramid. So the base on the bottom here is our triangle, and the area of the base is half times base times height. So half times the base of 8 times the height of the triangle is 14, so 56. The volume then is 1/3 of the base, so 56 times the height of the overall pyramid of 17. So 317 and 1/3 cubic centimeters. When a three-dimensional figure is sliced, two new two-dimensional faces are created, one on the bottom and one on the top. What faces are parallel to these slices? If I were to slice on the dotted line. So if I were to slice this first one here, the pentagon would have a pentagon on the top and a pentagon on the bottom. However, if I were to slice this next one, notice that I'm slicing right here, and I would go straight through the back here, so I would create rectangles. If I were to take this triangular prism and slice on the dotted line, and I were to fold it out and look at it, we would also see rectangles as well. If I were to take this triangular prism and slice it right down the middle, like kind of take like a piece of paper and slip it down through the top, I would get rectangles as well. If I were to take this square pyramid and slice down the middle here, notice that we would end up with triangles.